So yesterday, what we noticed is that when we were creating, when we were using like a int variable or something, right? Let's start from here. So if you would see, when we were using this string type, right? String as a value to be stored in a list, right? And in the end, when we were comparing it as per our logic, which was here, like this, when we were comparing it, we were seeing that we wanted to have a map which had a key value pair, and within that map, right, there was a need that we wanted to check that there is an existing value in the map or not, which by when we were using contains, right, contains key, and we found that when it comes to strings, right, it was able to say that so it was so let's consider this, right. So in case of strings, what we did was, let's consider this case. So we said s1 equals to Akhil and s2 equals to Jan here, right? Oh, sorry, Akhil again, sorry, Akhil, right? Akhil again. So what we were doing was, when we went back here and we were trying to add it in a list, right, like this input list, and we were checking in the contains key. Not sorry, this is a map, right? In the map, right, when we were adding the items in the map, when we were checking the items, right, in the map, we were checking with the method contains key, right? Contains key. So what we were doing was, we had this. What we are trying to do is, we were trying to create a frequency counter where whatever list of things we are providing, let's say this is a list. This is a list we are providing, right? Akhil, let's say Jan here, right? So what was happening was that there were three items. So in the end, what I was looking at, that it should say Akhil is one. So it's a key here. It's a value. So it's a string and it's a integer value, or whatever that we, okay, integer only, right? Integer. So we want to be here and Jan to be one, right? So for doing this, we thought to store this data in a map, which is a key value pair, and the name of the map was hash map, right? Focus on the word hash also, right? We will today also talk. We will today talk about why it is hash. Why? What is hash about this? Okay, what is a hash? So Akhil Jen, right? So when we were discussing about the strings, right, I was saying that if you do this, you will get such kind of an output, which was fine. Why I was saying you will get this, because in the string class, the developers of the Java, right, the developers of string class, what they did was, say in Java, right, we know that everything is inherited from the object class. So that is a case for string also. So string is a child of object class. So it receives. What does object class has? It has three methods. Okay, three important methods within it, which are useful for us. One is toString, second is equals, and third is the hash code, right? Hash code. Forget about hash code as of now. ToString we have already discussed in the comparable and comparator chapter. So it is just a way. Okay, let me say. So by default, right, the implementation which object class provides is, it says that if you print this, right, if you use this toString method inside any class, right, by default the implementation is that it will print the hexadecimal hash code value hash code value, or let's say, let me use the easier word, memory address, right, value of that variable, okay, of that variable. This is what the toString method does. What does equals does? Equal, we by default, right, it will compare the two things, okay, it will compare the two things. So if you so it will just say, you will pass the object here, right, you can pass on the object which needs to be compared. So it will be like o1 equals to o2, right? So this will compare. Now this is what it will do. Hash code again, let's leave it. We'll check that what is the hash code. So this is the three part, right? Now when the creators of the string, right, started developing this class, they did something intelligent, right? What they did was, they overrided the toString method, and they said, okay, I will not print this hash code, the hexadecimal value of this. What I will print here is, I will print the value which this string has. So it will just print the value. Let's say it was Akhil, right? So it said that I will only print Akhil as an output of this. So it was like this. So it will return Akhil, right? But if you know, based on a discussion about heap memory and the call stack, right, how this line gets stored in those two contexts, right? You have this as a call stack and you have this as a heap memory, right? What we do, we will say s1 here, which is a string, and there would be an object created here with the name as Akhil. And so what happens is it stores here, right? So here, right, it has a memory address location, right? So there is an address location for it. Let's say memory address one, right? So this is stored in the heap memory. Heap memory. S1 is pointing, and again, this is a call stack. This is a call stack, and this also has a memory address right here. So let's say the memory address is call stack one, right? Let's say this is the memory address for this, and for this the what I said, heap memory, right? Heap memory one. Let's say, right? Heap memory one is the memory address for this. So what is S1 pointing to? S1 is not pointing to directly to the value, right? It is pointing to what? It is pointing to this address, right? And at that address we have this value. It works like this only. Okay. So what happens is, if if they would have not overridden this, right, what they would be comparing is, they would be comparing the memory address, right? So if they would have not overridden this, it would have been, let's say here, right? Let's say S2 here, right? S2 here. Okay. So when you create a string like this, right, it creates in a string pool. See, there are actually 4 or 5 concepts getting used in a single concept to explain this. So okay, let me do one thing. Let me start from scratch. Let me say this. So we have this string, right? Let's understand about strings first. So in case of strings, what happens is we have 2 concepts. Let's draw a heap map. It's a heap memory, and we have this call stack. Okay, this is a call stack, right? This is a call stack. Let me create a memory address positions for heap memory. This is heap memory address, right? Let's say heap memory address. So there would be an identifier and there would be a value. Okay, there would be a value. Similarly, for the call stack also, it will be behaving like this only. We have our identifier, right? We'll have an identifier, and it will have identifier, right? So this is the identifier, and this is the value for it. Okay, and for this also, it will have this only identifier. Let me write here memory address. Memory address here. This would be the identifier, right? And the value that identifier has, right? This will be like this, and this will be if you can consider this to be like memory address only. Okay, so this is how it works. Now let's say we wrote this line, string s1 equals to Akhil. Now for strings, right, we have to understand when you write this way, right, what it does is a string has a string pool, right, in the heap memory. So it's a string pool. Okay, it's a different concept for strings. So it's a string pool. If you write something like this, right, it will add this value here in the string pool. So it will create an object here within the heap memory only, but here it will create Akhil here. So now this is what it's pointing to, right? And when you did this, right, what it did, it created S1 here in the call stack, and S1 is pointing to this, right? Let us add the memory address for this. So this has a memory address of, let's say, CS1. So you will say CS1, you have S1 here, and S1 is pointing to this, right? It is not pointing to this, it is pointing to, so Akhil is the value here, right? And what is the memory address for this? Memory address for this is heap memory 1, HM1, right? So what is S1 pointing to? HM1, right? Which is this part. Okay, now you write S2 here, and again you say Akhil, right? You do this string S2. What will now happen? Because you are creating like this, right, it will do what, it will again try it now this way, right? When you create a string like this, what it does is it goes into a string pool and checks whether there is an entry already or not. If it is already there, it will simply reuse that. Okay, that is how it is implemented in Java. So if you write this way, right, it will create a new variable s2 on the call stack, but it will go and check in the string pool, does there is an object of Akhil already there? If it is there, it will just go and point to that like this. Okay, so here you will have cs2, right, the identifier for this, because it will have some address position here on the call stack. S2 is the variable name, and what is pointing to? It is pointing to hm1 only, right? So there is no new entry in heap memory, right? There is no new entry in the heap memory address. Now see this. If I do now this string, okay, my system keeps on hanging. Okay, S3, right? S3, and I do this new string, and I say Akhil here now. What this will do? What this will do? It will, since you are creating it via this new keyword, right? Since you are doing it, since you're doing it with a new keyword, right? What it will do is it will not use a string put. It will create an object type normally in the heap memory. Okay. And here it will be creating a value Akhil and this, right? And what is the address for this? HM2, let's say. HM2. So it created a new entry, HM2, HM2, and Akhil will be placed here, like this. Okay. And you have another variable S3, S3, and the call stack value for this is I mean the address portion is CS3. So see here what will happen. It will say CS3. It is S3 here. What this is pointing to? This is pointing to HM2, right? HM2. Okay, and this is pointing where? This is pointing to a different object, right? Now, if you try to compare, right, these two string values, okay, if you try to compare S1 equals to S2, right? If you do this, right, or if you do this, S1 equals to S3, what do you think you should get? If I do compare S1 to S2, Fizula, what do you think? What should I get here? Fizula, you there?
Yes, yes, I'm here. Just thinking. Could you just repeat that once more?
So
S1 to S3.
see, what I'm saying is we have three variables S1, S2, S3, right? And S1, S2 I created like this. S1 equals to Akhil, S2 equals to Akhil, and S3 I created using this new keyword, new string. Now,
S1
because
and
I've
S2 will be
created,
equal, right?
it will be equal, so it should return true, right?
Yes. The other, it's in different memory space.
Okay, so what it should do? It should say false.
False, yeah.
Okay, you know that. Okay, so this is one thing. Okay, I'm not commenting on this part right now. I'll come to it. Okay, I'll come to it. But you have to understand that there are two. You can try to compare two things in Java by using two kind of operations. One is this double equal to, and second is like every class. Every class also has a method called equals here, right? Which they can use to make a comparison, right? So this is another thing, right? So if I do this s1 dot equals s2, let's say, right? S2 here. So what this will return and what this will return, s1 dot equals s3. Okay, s3. My pen is, I don't know about the pen, but this is the screen just getting a problem. Okay, so let's try to see this, right? For doing today's work, right? I'm not going to use the the FS programs repo. I'm going to use my Java repo. So let me create a branch here. Git checkout minus p day 29 for this, and over here, let me come back and let's in the main. I'll create. We're discussing about a new thing which is about uh, hashing thing, right? Let's say hashing, right? We're talking about hashing equals hashing. So let's create a new class very quickly. So we'll say string equals, let's say hashing demo. I don't want to create different classes. Hashing demo, right? And let's close other things, close other tabs. Let me very quickly do this. Main method. So now let's create string s1 equals to Akhil. Similarly, I'll copy this out, copy this, and place it here s2. S2, and let me say string s3 equals to new string Akhil here. Okay, now let us compare. If s1 equals s2, s out, same. Similarly, I'll use it and say if S1 equals to S3, same. Oh, else, let me create one method. Uh, public public boolean uh, uh, is equal, right? Like this is equal, and let me grab this, put it here, and I will take two strings s1 string s2. So these are okay, and I'm saying, let me not say this. I'll say return true, else return false. Okay, so this is what I did here. So now I'll just simply go and run this. So I will say, um, let me make it a static also. Otherwise, I'll have to create the object. Static, sorry, is equal hashing demo is equals if I pass on s1 comma s2, right? So okay, so it's equals to true, right? Let me print here only why to do it again. Uh, Same, and I will return not same, not equal, not equal. Okay, so let's run it. Let's see what do we get. So if I run the method here, I should get what? I should get an equal sign, right? Because both are equal. So both are getting created in the string pool only. So I should receive equal there. Equal, right? Now let's compare S3. S3. So we are comparing with S3. Let us see what do we get. We're comparing S1 equals to S3 now. Not equal. Okay. It is comparing not equal. Okay. Now let me do one more thing. If I do this S1 dot um, equals and I say S2 here, and I print this. Okay, let me get the value. Let me get a method for this also, because I will be calling these methods a lot of time now. Let me use this as this. Let me create is equal with method. That's it. So I'll say s1 s2, and I'm not going to do this. I'm going to say s1 dot equals here s2. And I'm going to say if it is equal, then it will say equal. Otherwise, not equal, right? So this will do this. So let's come back. Now I'm doing this is equal with method. I'm passing s1 s2, right? And I'm doing one more thing. I will compare this with the s3 also. S1 s3. Let us see the output of all four and try to understand what really happens. Okay, you see the output. It says equal, not equal, 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 right? Now let's understand what is really happening. Uh, when we compare, right? When I said when you will doing S1 and S2, right? Whenever you do, okay, let's focus on this part. Whenever you do this operation, right? Double equal to like this, right? By default, it compares the memory address, right? What it has. Okay, it compares the memory address. Now, if the memory address is same, right, of the value which you are comparing, right? See here, where it went here, right? So if you see this here, right, when we did this, right, S1 equals to S2, right? When we did this, what is happening here is here when S1 and S2 is doing, it is checking the address, right? This value, right? HM1 and HM1, right? It is not checking these. It is not checking these values here, right? It is directly checking only these value, right? This value is here, right? Only these. When you do what? When you do double equal to. When you do double equal to, it just checks the value which you have here. Okay, which you have here, right? So when we did s1 equals to s2, it said true, right? Because these are matching, both have the same values. When we did s1 double equals to s3, right? Again, it went here and checked, like, are these values same? No, these are not same. So this set false, right? So double equal to checks what? It checks here only in the call stack, like what is the value. Okay, that's it. It'll compare like this, right? And in case of strings, right, it stores the memory address of the objects which are stored in the heap memory, right? In case of ints, if you do something like this, let's say you have a variable like say int a equals to 1, right? And you have int b equals to 1, right? You do this and you write this. So what will happen? It will have a here and b here. It will be cs4, it will be cs5. And what they are pointing to, these values are here only, right? These values are here only. So what we will do is it will add two new entries to it, and entries will look like this: cs4, cs5. It will be a, it will be b. What are the values? 1 and 1. So when you compare a equals to b, it checks, okay, 1 equals to 1, right? Like this. It replaces whatever value you had here, right? So we get that value in case of primitive data types. But in case of objects, it is comparing the address. Why? Because there is a mapping required with the heap memory, right? I hope this is clear, right? Now let's move ahead. What are we doing with this? Okay, by default. Now, okay, now let's move to the next topic, right? I'll come back here. We know about the object class. We know that object class, right? Object class is the super parent of every class. String class is something which you did not create. It's a class provided by Java. When someone would have created the string class, right? What they would have done is they have overadded three methods inside this, right? One is the toString method, right? By default, in the object class, what it does is the toString method, when it comes from the object class, what it does is it simply prints the memory address of that variable, memory address of that value which you stored, right? Memory address of that value which you stored. It is like the heap memory, should I say, right? Heap memory address, right? Heap memory address. It prints that value, okay? It prints that value. Now equals to that equals method, right? Equals method. If you compare this, right, it will check what this equals method, right? Still checks the memory address only of the value which you stored there. Memory address, heap memory address is checked. Okay, if both objects have the same memory address, it means they are same. Okay, it means they are same. It again checks heap memory address. What is heap memory address? This part, this part here, right? This part here, it checks only this. It never goes to see to this value, right? It has not gone there. When you use toString, it prints this value, right? It prints this value, right? In case of it. And when you say equals, right, it is comparing these two values only. Okay, what about hash code? Park it. Okay, we'll talk about later. So but these two should be very clear: toString and equals method, right? Two strings just will print whatever value you had here, right? It is not the value which you're looking for, right? You must be looking for this value, right, when you say two strings. But by default, the ideal in the default case, right, what object class has provided is it will return this. Now the developers of string class, right, knows about this issue, right? So what they said is, okay, what they said is, okay, since this is a parent, right, since this is my parent and this is my, I mean, this is the child, right? So using the concept of inheritance, I have the power to override these behaviors, right? I have the power. So what I'll do is I'll override the toString method over here, right? What they did is they wrote the logic here, right? Instead of printing, so they will not print, they will not provide the memory address. No, they will not provide memory address. What they will do is they will go to the memory address, and whatever values is stored there, they will get that. Okay, get the value stored at the memory address. Okay, so this will do that. Okay, so it will do that. So in case of string, what is happening is, in case of strings, when you use toString, right, it will not print these, right? It will go and print, it will go and check what is the value stored at this memory address, which is a kill, right? So it will print that. Let me show you. If I go back here, right, and I say something like this, and I print s out s1 dot, ToString. Okay, if I do this, it will print ToString here, right? And then it will be S2 ToString, right? And let me say for S3 also, S3 ToString, S3 ToString. So it will be this. Let me print this. You will not see a hexadecimal getting printed. You will see only these, the actual values which the strings have, right? Akhil, 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 right? You can see, right? We will see the difference when we will create another object, which would be our custom object, right? But in case of string, this is how it works. Now let's, okay, so I hope this is clear, right? Now, now what the additional part the creators of string class did, the Java developers did was they also overrided this method, equals method, right? Equals method. Here also, right, what they are doing is they are now not comparing the heap memory address. No, they are using the they are comparing, right? They are here comparing the exact value, right? Exact value which is stored at the memory address location. At the memory address location. Memory address location. Right? So if I say now, right, if you so I hope this is getting clear, right? So it is not storing, it is not comparing the memory address, it is comparing the value which is placed at the memory address. So if I go back here, right, see this. When I was comparing S1, see here we understood now, right? Why this returned true? Because here we were checking the memory address. So here HM1, right, for S1 and S2. So this became true. When it said S1 double equals to S3, it is checking the memory address here, right? S1 equals to S3, which is HM1, this is HM2, which is not equal. So it returned false, right? When now we use these methods, like equals method, what equals method does within the string class, they have been overridden. They will not be comparing the this memory address, whereas they will go to the heap memory and they will locate the memory address for it, and whatever value you had, you will compare that. So here, right, when you do this, right, it is comparing Akhil with Akhil, which is same. That's why it is written true. Similarly, for S1, S3 also, right, it is doing the same thing, and it is although the memory address is different, but the value which they have is same. So this is written true, right? And that's why this is true, false, true, true. Fizula, this is clear, right?
Yes, yes.
Okay. Now, Sudhakar, hey Sudhakar, you joined late, but I hope, I think you can rewatch the recording and you will get the sense of it. Okay. Right. We are today learning about the equals method and the ToString method and the hash code. Okay. So this is all about string, right? So we covered the string part. Now, similarly, right? Let's say now I'm creating my custom class. So again, this would be any class which I create, right, is by default a child of the object class, right? So let's say I'm creating a class of laptop. I create a class of laptop. Here, what I did, if I show you what I did yesterday was, if I come back on this part, what I did here, laptop, right? I created a class like this, right? See here, right? I created a class like this, laptop, and it has a variable and it has a constructor, right? Now you can see I have not overridden the methods of ToStrings, and I have not overridden the method of the equals here, right? Let me copy this class and I will create this class in my Java repo so that we can have the information here only. So I will create a new class. I will create a new class of laptop here, and let me just paste this value here, and we are good, right? So you can see I'm doing this. Let me create this method here, and let me put all this logic into a method called uh, public static check string equality, right? Check string equality thing, so that our method is residing here. Okay, static, and it should be void. Okay, so this is clear. So now let's focus on that part. What are we going to do now? We are going to do this. We are going to say uh, laptop, right? So I'll create a value of this laptop L1. So let me say uh, Apple, right? Apple equals to new laptop, and I will say Apple here. Okay. Now it will be laptop. Let's say Lenovo. Okay. Lenovo equals to new laptop, and let's say Lenovo here. Okay. Now one last thing. What I'll do is I will create one more Apple laptop. Okay. Oh, sorry. And here what I'll do is I will say Apple 2, but see keeping the value as same Apple, right? Now let's look at the so once this line, three lines gets executed, let's see what happens in the call stack and what happens in the over there, right? So let me create it here. So let me draw the, this is the heap memory, this is the heap memory, this is my call stack, this is my call stack, and let me draw this like this, and this is the memory address location for this. So it will be identifier, sorry, memory address, it will be identifier, and it will be the value. Similarly here it will be the identifier, and it will be the value for it. Okay, like this. Now memory address, right? We created laptop Apple equals to new laptop, right? As soon as you do a new laptop, right, it creates an object here, and it will be having a value of, let's say, Apple here, right? Apple here. And let's say so for the first entry would be, let's say it went here, it said Apple, right? So Apple is placed at CS1. So CS1, and Apple is placed here. Now this is created here, right? So a value would be created here, Apple, let's say, right? I mean the object. Let me tell you, right? This is a laptop object, right? So let me write it here like this: laptop Apple here, right? So this is this, right? It is not a string. It is something else, right? It is not a string. It is an object here, right? It is an object here, laptop. Now, what is the identifier? Let's say the identifier for this is heap memory one, right? Let's say so heap memory one. So what will this point to? This will point to HM1, right? So what are we saying is this is pointing to this address here, and this address is pointing to this, right? Like this. Now I create another laptop, Lenovo. Again for Lenovo, this will be CS2. This will be Lenovo. It would be HM. Sorry, let me get a new object first. This is HM2, and this will be Lenovo here. So it will be HM2. It will be laptop. Will be Lenovo, right? Lenovo, right? So it did this. So HM2, right? This is pointing to HM2 here, right? HM2, right? Like this. I mean, using this and this, it goes here, right? Like this. Okay. Now the third part. I created one more variable, which is Apple 2. Apple 2. So this is CS3, right? This is 2, this is 3. And I'm creating a variable with the name as Apple 2. And this will, since it has a new keyword to it, right? While I was creating, it will create an object like this. It will be HM3, and it will have Apple only, right? Apple. So this is HM3, and we have laptop and Apple only, right? Apple. So if you would see, right? I mean, the value of the laptop name is same in both the cases, right? Apple. But these are different location, right? These are different objects altogether, right? So this is pointing to what? This is pointing to this HM3 here, right? Now this is pointing to HM3, right? So this one is pointing to this is pointing to this, and this is pointing to this, right? I hope this is clear, right? Sudhakar, right? I hope this point is very much clear. Now let's see this, right? We'll go back to the program, and what we'll do is this is the leftover, right? Now let me print the value of the ToString of this object here, right? Apple here. Apple, if you will see, right, it already has a method ToString, right? If I print this, what do we get? Let me print it for all three: Lenovo and Lenovo, sorry, Apple 2, right? So let's print this. Let's see what happens. In case of string, when you were using ToString, right, it was printing the value which the string had, right? Which was this. You could see this. In case of string, it was when I was printing two strings here, right? It was printing the value it had, right? It was not printing the memory address location, right? Okay, why? Because the developers of the string class has overridden the ToString methods. But here, did we override the method of ToString here? No, right? We have not done that. And that's why when you use ToString here, right, what is happening is it is working as per the default implementation, which prints the memory address of this object, which is this, okay, the hash value or something, right? It is printing that. You can see all three values are different. Now let us say that I am done with it, and I think that this too strong. I mean, let's say my intention is that instead of printing me this value, right, of this, it should print me what? It should print me the value of the laptop name, right? Let's say I want to do that. So what I will do here is I will go to the laptop class. This is the class, right? And I will myself override the toString method. Okay. So let's say override, and I will write toString public. What is the toString? What is the written type of the toString? It is string only. Okay, public string, right? So I will say public string to string. Okay, like this. I'm overriding it. What I will do here is in in the default implementation, it would just return the memory address. I don't want to do that. I would rather return what? This laptop name. Okay, copy this and this value. Okay, I'll return this value. Now let's print this method again. Let's see what do we get. You can see, right? Apple, Lenovo, Apple, right? Right? So we were able to override the behavior, and this is what the developers of the string class have done, right? They have overridden the toString method. Now the next thing, right? When we look at the other method, right? Let's say now I want to compare. Now I want to compare. So what I will do is I will call these methods now, which are these, right? Check string equal to, no, this one, not this one, right? Is equal. But these are talking about string. So let me create my own method here. Instead of string, I think I can provide object, right? So this will also work. Object and object. Okay, object, because everything is an object, so this will work. And here also I'll provide object only. Object and object, right? And you can see they are working, right? I don't have to make any other change. These are working, so let it be. What I'll do is I'll first use this method, is equal method, right? Let us see what do we get. So I am, and again, let me just reverse this changes which I have done here, right? Let me just reverse the changes. Let us work without them and see what do we get as an output. Okay, so if we go and run this now, we are saying, let me call this method. What was the name of the method? Is equal, right? So I want to say, I want to check, is apple equals to apple 2? That is what we are trying to see, right? So it will go and invoke this and it will tell me, right, whether it is equal or not. Let me run this, right? Let us check. Is apple equals to apple 2? This should return false, I believe. It should say not equal, right? It said not equal, right? Mind you, when I'm running this, I have removed that overridden logic, right? Let me remove the logic here, right? Let me see if there is any change because of this or not. If I do this, right, I don't think there would be any change, but let's see. It should still say not equal, right? Not equal, right? It says not equal. Why this is saying not equal? Because here, right, you are doing with which operation? You are doing this double equal to, right? You are saying double equal to. So now the right time to understand here is now is that when you use double equal to, right, you cannot change the implementation of how double equal to work, right? Because there is no, it is not a method, right? It is an operation which Java provides you, right? Double equal to. Whenever you're doing this, right, s1 equals to s2 here, right, it will still go and check this only, right? It will go and check this value, right? It will go and check this value only, right? So if you now use this apple equals to apple 2, right, you will always get false, because these are two different objects, apple and apple 2, right? These are two different objects, h1 and hm2, right? If I would have compared lists, right, if I would have compared two apples, right, the same objects, you would say, it would say true here, right? It would return true. Then you can see it would return true. Still running. It would return equal, right? It returns equal, right? Because both are same objects, right? This is clear, right? Fazula, this is clear, right? Sudhakar, this is clear, right? What we are doing. I cannot see if you,
Yes, yes.
right? This is clear, right? Now double equal to, we are clear, right? Now if you say apple equals to apple, these are clear because these are the same objects. Apple is same object, right? So we understood this part, right? That when it comes to equal to, always understand that this only compares this column, right? Whatever the value will have, just compares it. If they are same, it will say true. If they are not same, they will say false. Now coming to the next method, right, which is the equals method. Let us see that what happens in that case. So if I say, if I do this, now if I say this, apple, sorry, is equal with method, right? So I'm saying apple and apple 2, right? Apple 2. If I do this, what will happen? This is the method we're talking about, right? It is going and comparing like this, right? Equals method. It is using a equals method now. Equals method S2, and it is saying this, right? Let us run this. Whether we get equals or not, we should get not equal here. Let's try to run this. Not equal, right? We are getting not equal. Let me just comment this part. So we are getting not equal here, right? For this. If I now run apple, why we are getting not equal, I hope it is clear, right? Because the default implementation of the equals method, it does what? It still checks the this only, right? It still checks this. So the default implementation of the equals method that any class can have, right? It goes and check this column only, right? Right? If you want to override that behavior, that instead of this column it should check this column, then we'll have to do something, okay, or something else. Okay, we'll see that. What we have to do is, we'll come back.
Just one doubt, Akhil. What
Yeah,
was the purpose of this equal one? It's just to override, right? Because if you don't override, then there's no meaning to it, right?
equals one, right? Yes, you're
Yeah.
absolutely correct. That is, see, the purpose over here is to make sure that if you compare two objects, let's say you want to check, if you're comparing two objects, right, and you want to say whether these two objects are same or not, right? So by default, if you have two objects, right, they can never be equal, right? Because both are would be assigning, both would be having two different address locations, right? Agree? If you create two
Yes.
objects in Java, they will always be different. They cannot be equal, right? Now, and if you want, if that is what you wanted to check, you can use double equal to, right? Because double equal to will always check the memory address of it. And for two objects, memory address will never be same. So in case of apple, right? This, if you compare two similar objects, the same objects, exact same objects, they will have the same address and they will become equal, right? But so what Java said, okay, that maybe the two objects, right? Let's say in our case, right? These are two different objects for sure. These are two different objects, apple and apple 2, right? But let's say, but the value which this laptop object has within it, right? Apple, like laptop name, right? Let's say you want to make a decision on that basis, that these are equal or not, right? But with the usual approach of double equal to, you can never compare that value, right? So what Java said it, okay, let me introduce a new method which is equals, okay, and I will give you a liberty that by default I am providing the, I am saying by default Java said by default it will work as double equal to, right? So this is the default case. So it will work similar to double equal to, right? But you still have the chance to override this, right? And what you can do here is, instead of comparing like comparing like this, right, which is taking the memory address, which is taking your memory address, what you have the provision now is, you have the liberty that you can go and instead of checking the memory address, you can check the value here, like these, right? So you can check, you can make a decision now based on these values, whether these values are same or not. If these are same, you can come and say, okay, these are, that these two objects are equal. Okay, that is the whole point about the learning about the equals method. Okay, so let me just finish this. I think it will make start making sense. So is equal with method, right? Is equal with method, I'm checking this and it is comparing this, right? It is received apple and apple 2, and we are checking apple dot equals apple 2, right? And we found that it still returned not equal, right? Because we have not overridden the dot to equals method. Okay, now how equals method works? Let me come to that point now, the last point. Okay, how equals method works? How does this equal method works, right? What it does is, it goes inside the class. So we were doing this, right? Apple equals apple 2, right? We were doing this like this. What it will do is, it will go and check within this class. Okay, it will go and check within this class that in within this class, right? We this is an object of which class? Laptop, right? So it will go and check there. Do I have a equals method being overridden or not? Right? If it does not have this overridden method, let's say this is not there, it will use the usual approach of using double equal to, where it will always say false, false, right? Where it will return false. But if your class has an overridden method of equals, right? This equal method, right, will go and run this method. Okay, not the default implementation. It will go and run this, right? And here you can add the logic. You can add the logic, and here you can make a comparison based on the string value. Okay, I mean the value, like which is the laptop name. Okay, you can make a comparison based on this laptop name here, right? This which is a string value. How we'll do it? Let's just finish that part. So we went up. This is the hashing demo. Double equal to equal, right? Okay, so we did this, right? We have overridden this, and let me run this. So ToString will not have an impact. Let me just run this. ToString. Apple, right? We are comparing. We have not implemented equals method still. I just want to check this. Not equal, right? So let's just now override the method. Let us override the method of equals here. Public. Uh, what is equals returns? Let me check here. If I say, if we come back here, let me say uh, Apple dot equals returns you what? It returns your boolean value and it takes an input of object, right? So let me remove this. Returns boolean, right? So let me, I will come up here. I will return a boolean value and I will override the equals method. And here, right? Now try to understand what value do you expect. See, if I go to the object class, let me go there. Object, let me go to this class. If you go to this class, right? This class has hash code equals here, right? You can see. So we'll have to, if I want to override this, right, I will have to have the same logic, and it takes input as object, right? The object class only. When we are dealing with here, right, with the laptop, see, when I want to compare things, right, what I will be comparing? A laptop to a laptop, right? So what should I do is I should mention here laptop. Okay, and I will say here, let's say, um, let's say laptop only. Okay, let's say this, right? So override it. We are doing this, and we need to return a value. So I will now check it here, right? I will compare it, right? If, right? See, I will say if this dot laptop name, right? I can do this also equals to laptop dot laptop name, right? Then return true, else return false. Okay, why is this still comparing? Uh, Method, what is saying? Method does not override method from its over class. Extract method equals to new interface. This is the problem here. Just a second. I've written this only, right? Public boolean equals return this. Okay. No, this is yes. What is the problem here? Just a second. Equals here, and we are saying it is complaining. Why it is complaining? Because of this. Why is this saying it is not overriding? It is overriding, right? More actions. Okay, let me do one thing. Generate uh, override methods, and we have this equals method. And let me do this. If I do it, what is the? I'm doing the same thing, right? Why it is complaining? I'm not doing it. Okay, let me write the entire logic here. Okay, maybe I am doing this part, that's why it is complaining. Okay, I got this. Okay, let me try. So I'll copy this, I'll return it from here. I'll say this part, and here it says this. So if I do, let me say it as laptop, and if I say laptop here, it has a problem. It is saying it is not override because we are down scoping the value. Okay, so let me say object here. Okay, and no, this is not correct, right? Why it is complaining here? It should be laptop only. Extract method equals to new interface. Extract method equals to new interface. No. Okay. Why is this complaining? Should have not have complained. Okay, let me do this thing. Let me, as of now, just to make things work, let me do this. But I am strange that this is strange that this is behaving like this. Uh, I want let this be an object only. Obj. What I'll do is I'll downscope it here. So I will convert it like this. I will say laptop, and I will convert this obj thing. I'm downscaling this, and I will say, and here dot laptop name. Okay. So I'm doing like this, and this is overwritten this. I'll come back and now run this, right? Earlier, if you remember, it printed what? It printed not equal here, right? It printed not equal here. Now, if I run it now, right? Let's see what it will do. This should return me a true as per my best understanding. Okay, you can see it returned equally, right? Why it is returning equal? Because this time when you invoke this method, right, it went to check this method equals here, right? You can see what it is calling. When it says s1 not equals, so where it does it go? Right, okay, here it is the object class, right, where it goes, but the implementation where the it has gone is this method, this equals here,
Just
right?
one doubt,
Okay.
Akhil. If
Yeah,
we don't downcast, I mean, without the casting also, won't it work? In line number 21.
I was trying to do that, but it was throwing an error.
No, directly just the object dot laptop. And if we do that,
No, because object, right, does not know about laptop, right? Obj is object
okay,
class because it's a
okay,
parent,
okay,
right?
yeah,
Parent does not know about childs. You will have to downscope them and then access the value, right?
yeah, yeah, got it.
Child knows about parents, parent does not know about childs, right? That is how it works. But strangely, I was thinking it should be laptop here, but I mean we should be able to provide laptop here, and this is giving me the error. It is very strange, but I think maybe that is how it works. I don't even very clearly
No,
remember.
I have worked on it once. Like it was object only. We had to override that object only at that time. Like when for a assignment, right? You gave this one, right?
Right.
So that time object only I had to use. When I tried that.
Okay. Okay. Maybe then maybe I have some other understanding. So I think, but at least we are able to achieve it, right? Now we have achieved this, and now using this equals method, whenever I would be using this equals thing, right? It will go and check this only, right? But again, if I still use this double equal to, I'll still get not equal, right? Let me show it again. So if I run it, still I run this, right? This will still return me what? This will still return me. Let me compare this. You can see, right? The below one is returning me true, and this will still return me false. Why? Because we cannot change the implementation of double equal to, right? We cannot change the implementation of this double equal to. This will still compare the value which is placed at the call step. But here we can override that behavior by whatever logic we want in the equals method inside the class. Okay. Now, why we learned all this, right? Let's just get to the last point. Why we learned all this? Because we were facing an issue, right? If you go back in our previous program, right here, we were doing what? We were. Let me go very quickly. Frequency counter. Just a second. Let me switch on my charger. Otherwise, my laptop will crash. Okay. Yeah. So what I was saying is, if you see this right, in the frequency, this was the logic which we were writing yesterday, right? This was the logic where we were checking that frequency list string, right? Where we were writing the logic for frequency counter. Here, while we were doing it, right, we were checking in the frequency map, right? This part for the strings. For the strings also, we were checking like if you want to validate whether there is a key already in the map, we use this method, right? Contains key. And since we were using string in this example, in this method, right, it works fine because string. See how the map will know whether the keys are same or not. It will depend on the value, right, for the strings. So what I'm saying is, if I go back very quickly, let's go. So why we learned all this today is because when it comes to maps, right? Let's say in hash map, right? What you did, you created a map, right? Map here, and let's say whatever that map was, right? New hash map, right? And you give the value, right? You are using what? You're using string as the key, and maybe integer as the value, right? We were doing this, and string as the key and integer as the value. Now we already know the string class has overridden both the methods, toString also and equals method, right? Equals method is very important here, right? So what happens is, when you wanted to check this, right, you had a logic where you were saying that this is our list, and we were saying uh, Akhil, Jan, Akhil again. So the output should be in the map should be like this. So map should form like this. It should say Akhil here. It should say 2, and Jan, for Jan it should say 1, right? So this is my key. This is my value. What is this? This is a string value, and this is a integer value, right here. When you were comparing, right, the logic was saying that we will read this value one by one, right, and we will check whether we already have it in our keys, right, like this, right. Now when the map method use, how map checks it? Map checks it like this, right? It says contains key, right? Contains key. So here when you provided, let's say Akhil, right, let's say in the initial part, right, it will check. How it will go and check here, right? Is there a key with this value, with this value, right, with this value? Okay, but in Java, right, every string is like an object here, right? It's an object. Still would be an object. So it is seriously going and checking this object here, right? And checking whether it exists or not. How the comparison is happening? The comparison can only happen. I mean, this is happening correctly here because string method has overridden this equals method, right? Has overridden this equals method. When it would be comparing this Akhil with this already existing value of Akhil, right? It is not comparing the memory address, it is checking the value here, right? And that's why it was able to get, if there was already a value here, right, it was able to say, okay, the contains key already is true, right? If it already had Akhil there, right, let's say it was 1, it was 1, Akhil was 1, Jan was 1, and you were adding this third value. When you done this, right, it goes and check, does my map already has Akhil? It's an object, right? Remember, it's a string value, it's an object. So it is checking here whether I have it Akhil or not. How it is checking? It is checking because of this equals method, right? It is checking these values, right? So that's why it returned true. Since it returned true, what we did was, in the existing value, I added 1. So I got 2 here, right? But in case of car, in case of laptops, that was not the case. In case of laptop, what I did, I created this, right? I created something like this. I said new laptop Akhil. There was, sorry, Apple, right? Similarly, Lenovo, and then Apple. What happened here in this case? These are three different objects. Three different objects. In the first object, right? It checked. Do I have? Let's say here, right? It checked here. Do I have Apple here, right, or not? It checked. No, there is no Apple. So it made an entry here in the Apple, right? And look at this heap memory here, right? So it created an Apple object here, right? So it's an Apple object, right? Now this is new laptop app, new laptop Apple here, and it has a memory address, let's say HM1, right? Now it went to see this, right? The new entry was about Lenovo. So it checked, does it contain new Lenovo, that part, right? What was this? Lenovo, right? A new laptop, Lenovo, right? So again, for this, right, it will go and create this object, right, and check new laptop, and this was the Lenovo part, right? So this has different address. Now these two are okay. These are doing like this, right? New laptop and all, right? But what about the third part? When it goes to the third part, right, which is Akhil again, I mean, sorry, the Apple again, right? What it will do is it will go and check. You may think that you are providing this here, right? Like apple here now. You may think, okay, Akhil, that apple is there, right? But is it really checking the apple value? No, it is checking the memory address of this entire object, which would be different, right? It would be HM3 only. So it will be apple, it will be HM3. Does it really exist? No, right? It does not exist. It does not exist because we have not overridden the equals method inside that class. So it will go and add a new entry inside this, right? So it will be saying 111, and this is what we were getting yesterday, right? How, if you want to change this, right? What we can do is, now let me show you the behavior. I will simply do one thing. I will go and update the value of equals there. We'll go to this method. Let me run it again just one last time and see that how it really worked. So this is frequency counter demo. Uh, this is my test case. So test laptop frequency, right? Like this. So if you were doing this, right, laptop, this, we were getting what? This was an array list, and laptop Apple this. We were doing this. Okay, let me just comment this out. Okay, so we commented this out, and let me just make it very simple like this. I'll not add 5 values. Let me just do this. Lenovo Apple, right? And let me stop this. And I'm saying frequency result list object, right? And then we are providing the laptop list. So if I run this way, right, I think it should work as is. And let me just run it. Let me run this method. So we should get Lenovo 1, Apple 1, Apple 1. Okay. It should be doing this. You can see, right? 111, right? It did this. Okay, let me do one thing. Since it is printing this, right? So you can see there are two issues, right? It is giving the memory address first of all, right? And it is giving 111, right? Let's solve both of them by using both the methods which we learned today. So we'll go to the laptop class, which is here, and I will override the method of ToString first of all. I will say public string ToString, and I will say return what? Return laptop name. Okay, this part is done. As soon as I do this and run the method, you will see it will start giving me the. It will not give me this address here. It will give me Lenovo Apple, right? One is this thing. Second thing, what I will do is public boolean equals object obj here, right? And I will say what I will do this. If this dot laptop, right? If this dot laptop, uh, okay, sorry, this dot laptop name, right? Name uh, equals to uh, this part, which is laptop, and obj. Let me put it into brackets. Uh, dot laptop name, right? Then I'm saying return true, else return false, right? Now let's run this. Let's see what happens. Okay, let's see what happens now. If I run this, right, we are currently getting Lenovo 1 and Apple 1, right? And we were getting Apple as 2, right? Let me now run this and see. What do we get? Okay, we still get Apple 1, right? Why we are still getting this? Okay, what happens here is, if you see this method here, right, which is making the comparison, where we are making the comparison, we are making the comparison at here, right, at this method level. This contains key, right? This contains key. Now the last part of our discussion for today, we'll continue tomorrow. The last part is in the contains key. Whenever this method runs, right, it is not only checking the equals method. Okay, it is not only checking the equals method. There is something called hashing also, right? There is also called something called hashing. So both the values should match. If both the values match, only then it will compare those two things as equal. Okay, so here we have made we have used the equals method, but we have not used the other method, which is we have not overridden the hashing method. Okay, and that is still using the default case. So tomorrow we will update that method also, and we'll talk about hashing tomorrow, like what exactly is hashing, and we'll try to incorporate it, and we'll see that this will improve, and you will see Lenovo 1, Apple S2. Okay, and this is what we will do tomorrow. I hope today class was, I mean, you got what we I wanted to share here. We stop sharing, and this is what we wanted to cover. Okay, any doubts, any questions you have with respect to what we covered today? See, every object class is a very important class, right? It provides three things: toString, equals, and hash code. Okay, and these are very important when it comes to collections framework. Okay, if you are if you are not using any custom class, let's say you only want to deal with integer or string, right? Then there is no need to update any of those methods. There is no need to override any of those methods. ToString, equal, hash code, don't override. They are already overwritten in the string class and they will work. Similarly, for the wrapper classes like integer, boolean, character, right? All these classes also, the default implementation is already provided for all three methods: toString, equals, and the hash code. Okay. So for all these classes, there is no need. If you want to just use only these three things inside your collection framework, then there is no need to override any of this method by yourself. But as soon as you keep start saying that, okay, I will be using my custom classes, right? I will be using my custom classes as the keys in the hash map, right? Then there is a problem. The problem is when the contains keys check whether the two values are same or not, right? In case of string and all, we it will be able to check it, right? But when it comes to the case of the custom objects, it does not know, right? It only depends on the address, right, which is stored in the call stack, right? It just compares that. If they are not equal, it will say they are not equal, and it will treat like a new entry. Okay. So what we have to do, what is, we have already done one part, which is we have updated the equals method. There is something called hash, which we'll talk tomorrow, and we'll understand like why this is very important for us and why we say it as hash map, right? We have to understand what is hashing about it. Okay. Even hash set, right? There's a concept of hash set also, and there are more, right? But we'll talk about hash map and we'll wind up the discussion tomorrow. Okay. Okay, thank you so much. There is nothing more which I wanted to compare, just wanted to give a highlight. Okay. Okay, thank you. Let's meet in the evening class for the boot camp.
Thanks. Bye.
Thank you. Bye bye. Take care.